From legacy servers, to VMs, to containers, to Kubernetes. How did we get here? In this video, we're going to be talking about why we use Kubernetes. I'll be taking you from an example application or website in a legacy data center, all the way through the progression of moving into VMs, and then moving into containers and into Kubernetes. Now, it might not be a very long video, but hopefully it will explain how that worked and why we are here today. I'm going to be using my Wacom tablet to draw the little images that you're going to see. And as you'll see, I am an amazing artist.
Liar.
So, you know, put my stuff in a gallery is all I can say. Yeah, I apologise for the artwork. It's not great. I wouldn't even call it artwork. I would call it scribblings on a page. And that's what you're going to get. But hopefully it will explain the progression from data center to the cloud and Kubernetes. So let's get going. Okay, so in this example, I'm just going to say back in the day, you know, I used to be a small business, for example, and I used to have one server in a rack. Okay, so here is the rack. And here is my single server in there. And this server would have things like a web service installed, a database service installed. Let's just write this out. Okay, so it have, let's say, Nginx. It would have Postgres, SQL. It would have Postfix, I think it was, for mail services. It would have Bind for DNS, because, you know, this is how long ago we're talking. And it would have PHP installed to handle the PHP element of the website. And it might have disk space for storage. And I'm not going to write anything for that because, you know, it's just disk space for storage and that would just exist on the server anyway. And this would be fine, okay? I was a small website, for example, and I didn't have a lot of traffic coming in, so this was absolutely fine. But one day I started getting a lot more traffic in because my business exploded in some way or another. And it meant that now I was getting a lot of web traffic coming in and Nginx was getting hit pretty hard. So I decided to add another server to the rack and I called this one Web 1. And I removed Nginx from that server. So now it just had Postgres, Postfix, Bind, and also removed PHP because, you know, PHP was part of my web service. Now I'm going to move all my files onto this particular server and any request to a database just go up to the original server. Brilliant. I've now got a website with a kind of web server involved in my little cluster and that handles all the traffic coming in. The database isn't really hit very hard, so it doesn't matter, neither are the mail servers or the DNS servers. But then one day I decided to add a store to my website and the database has started getting hit a little bit harder. So I decided to then add another server into my rack, and that's going to be called database 1. So now I can remove Postgres off here as well. So now this is just my mail and DNS server, okay? This top one. That's great. You know, I've now got the web when, you know, all traffic comes in and hits the web server, which then when doing database stuff, hands it off to the database server, which will then respond to the PHP in the way it needs to with any data it needs and then returns that to the user. Great, that's cool. And then all of a sudden, one day my mail service starts going overboard as well because, you know, my mail list has grown exponentially and I'm sending lots of emails out when people are putting orders in and, you know, my mail server is really starting to get hit. And so what we did was we added another server, we made this our mail server, and you know what? Now that there's nothing else on this particular server up here, we just called this our DNS server. And now we've got a little rack of 4 servers and it does mail, database, web and DNS. And this is fine. You know, our storage is part of the Web 1 because that's where all the storage needs to be. You know, database has its own storage, which sits on the database server, and the web has, you know, images and things like that, which sits on the web server. And that's all we need for our little website. However, we've now got the problem that I need my website to be up and running 24/7 because I cannot have any downtime on this particular website because people around the world are now using my website. So what I decided to do was add in another web server. So we'll call that Web 2, another database server, which we'll call DB2. And just to make sure we've got redundancy on everything, of course, we've got Mail 2 and we'll have DNS 2 as well. We've now got redundancy. We also added one more server in there, or we're not a server, but a load balancer. And that load balancer will basically have the traffic come in and then it will either hand off to Web 2 or to web 1. Brilliant. So now the traffic will come in, it will round robin, so it will hit web 1 first, then the next request would hit web 2, the next request would hit web 1, and so on and so on. And this is brilliant. You know, we've now got a highly available website. If when web 1 gets overloaded or goes down for any reason, web 2 will respond. The other option would be that all traffic just hits the 1 versions of the servers, and should any of them go down, it fails over to the 2 versions of the servers. So either way you look at it, we've got some highly available setups going now. Problem is, we've now got 1, 2, 3, 4, 5, 6, 7, 8, 9 servers in this rack. And 9 servers in a data center is not cheap. So this was fine back in the day. It did the job and it did what we needed it to. It's all fine. But obviously it's expensive. And the other problem we've got with this, if we actually zoom into the web server, for example, and we'll have a look at web, and this has just got Nginx and PHP on it, and the web files, so I'm not going to write that, but you get the point. In reality, on a quiet day, I was using about this much of the server in terms of resources. There was a lot of CPU and RAM in these to make sure that they could handle the high load of traffic when it burst, but when it wasn't bursting, this is how much I was using. When it did burst, you know, I could go up to, let's say, 80% with maybe this much not being used. So only 20% of the resources being wasted. But on a slow day, I could be using as little as 10%, 20% of the resources in total. So in reality, on a slow day or a quiet time of the day, all of this is going to waste. It's not great, but it is what it is. Then came VMs. So VMs changed everything for us. So now we have this rack, and instead of having 9 servers, we just have 2. And we have S1 and S2. Let's zoom into S1, for example. So this is where VMs came in and made things a little bit better for us. So we could say, right, well, you know, we had web 1, database 1, mail 1, DNS 1. So we'll do DNS, that's a D, not a P. DB 1, mail 1, and web 1. And these were exactly the same as the servers we just had that were physical, but now we've got VMs. And this server was maybe spec'd a little bit higher than the original server, so it could support all these VMs, but it was nice because I could just have 2 servers, and, you know, all of the resources I needed were in this one server. And then my second server was just a replica of this. Let's just draw that in for the sake of it. And then my load balancer could do the same. It could basically keep traffic going to this server, and then if it ever went down, fail over to that server. So I've now still got my high availability set up, but I'm only in 2 servers now, so that's great. Problem is, I've got all this resource being wasted here. So this is maybe, let's say, another 10, 20% of wasted resource, because we don't need to use that much space. And on top of that, the web 1 VM, for example, was spec'd to manage burst traffic. So actually, again, on a slow day, I'm still only using this much of this VM. So in reality, if we actually look at how much I'm using here, let's just overlay the amount of usage we use from each one of those VMs, and we're still only using a tiny bit of the server when we're at idle, essentially, or on a slow day. On a burst day, we could use all the way up to this, like say 80% or something like that. We might spec it out so it uses 100% of the resources with just enough left over for the host system, but even still, there would be wasted resource. But again, this was fine. It saved money in the long run because I only had 2 servers instead of 9. And it meant that I could spec these VMs up to what I wanted to, and if I ever needed to, I'd just add a new server with all that replicated over, and the load balancer would include it, and that's fine. Then containers came along. Containers were good because they allowed us to utilize more of a server. So I won't draw the rack again this time because I think you get what a rack is supposed to look like. But we would come along and we'd say, right, okay, well, we want an Nginx container in this case. So Nginx container was much smaller than a VM for starters. And that is because it doesn't have an entire operating system. It just uses the host's operating system. And I'm not going to get into what that is right now. That's not what this video is about. This is more about the infrastructure side of it. And that Nginx container would sit listening on port 80, and any traffic would come in and hit that and respond as needed. And it's the same with the databases and everything else that we've just been talking about. The problem with containers, though, was the scaling. Now, if I wanted to add another Nginx container to handle more traffic, so I'd say maybe this is worth, on an idle day, we knew it could sit at maybe 200 milli CPU. So that's an M. And that's fine. On a bursting moment, then it could go up to maybe, let's say, 800 for this example. And that's like 0.8 of a single CPU. And then we could say, right, well, you know, on a really heavy day, I actually need more than that. But rather than keep expanding this container out, what we can do is we can add another container that's Nginx. And this has the same spec. It's got 200 minimum, and it can burst up to 800. And that's great. Problem is, this doesn't listen on port 80 because port 80 is already in use. So this might have to listen on port 81 instead. So now we need some sort of load balancing system that basically passes traffic to port 80. then through to port 81. And then if you add another one on 83, then, through to port 83 and so on. Docker Swarm eventually came along to try and resolve some of these problems, but it wasn't perfect. It had its issues. Now, again, this was fine to a degree because I could fill up more of this server in terms of its usage, okay? So I could just literally cram it full of containers to the point where barely any of the server was going to waste. And I've got one server managing everything that I need here. It's really good. And again, I could just have another one that fails over should I need to. But like I say, we had that problem of ports. So this is where Kubernetes comes in. Kubernetes came in and basically solved that problem. I'm not going to talk about the entirety of Kubernetes right now, but in a real small nutshell, the way Kubernetes would work is you have a pod, which is a collection of containers or a single container. And that pod can contain, for example, Nginx. And this pod can listen on port, let's say 32006. We don't care, port 80 inside, but it translates from that port into this port. Okay. Then what happens is you have a service, an SVC, which listens on port 80. So traffic comes in, eventually gets to here, hits port 80, and then the service offloads to this port on whatever node it might be. And the good thing about this is I can then add another pod, and that pod can start listening on 32007. And because of the way Kubernetes works, that just automatically gets registered with this service, which then can start forwarding traffic to it. And I can just expand for as long as I want, for as many ports are available, for as many pods as the node will support. And that service will just keep adding those extra pods in. And no matter what happens, I can still come in on port 80. The service will know that I need to translate that over to one of these Nginx pods, and the traffic will hit any one of these, respond, and you've got your website up and running. And again, this is the same with databases and anything else you can think of that would run in the container originally, but in Kubernetes. And that is, in a nutshell, where Kubernetes comes in to replace the original infrastructure. And there we have it. That's how we got to Kubernetes today. Now, that's not to say that everybody should use Kubernetes, because there's scenarios where you shouldn't use it and there's scenarios where you should. I won't be going through them right now. But as a quick example, if you've got a tiny blog on a website that doesn't need scale, don't use Kubernetes. It will cost you a lot of money. So in the next video, we're going to be talking about things like setting up the tools used to interact with Kubernetes, so kubectl. We'll then move on to installing Minikube or Kind. We're going to cover both, so it's up to you. And therefore using tools locally to deploy clusters on your local machine so that you can, develop locally without the need for a big expensive cluster in a cloud. Then we'll move on to installing a cluster. We're going to use VMs for this, but the concept is the same pretty much across the board, no matter where you do it. Now, the VMs that I'm going to be using, I'm not going to show you how I'm going to set them up. There's a video appearing now, and that video up there will show you how to do it. Well, it will show you how to install Ubuntu anyway on a VM. I'm going to be using that process pretty much without the RAID, but it doesn't really make a difference. Set it up with or without RAID. And we're going to use maybe 3 to 6 VMs to get going, because we're going to start with a single node control plane. Then we'll go into a multi-node control plane, and then we'll go into high availability with etcd outside of the control plane. We're going to do a few different varieties of installing basically a cluster, because there's many ways to do it. And yeah, then we'll move on to actually deploying stuff and security and volume management and more. So I'll see you in the next one.